In Chapter 4, we discuss project scheduling. Today we're going to talk about 3 of the 4 project scheduling tools: the Gantt chart, the critical path method, and the program evaluation and review technique. The Gantt or bar chart is the most common type of scheduling tool. It represents project tasks by bars. The length of the bar represents the time it will take to accomplish the task. The tasks or bars are arranged by time. The critical path method, or CPM, is the scheduling tool that places tasks in a network or flowchart of project tasks. Using time estimations for each task, earliest and latest start dates can be computed for each task to get the project completed on time. One sequence of tasks will constitute a critical path of tasks. A critical path of tasks that need to start and end on time for the project to finish on schedule. The program evaluation and review technique, or PERT, is also a network or flowchart of project tasks like that produced by CPM, and it directly addresses time risk in a project management. If you're interested in learning more about the graphical evaluation and review technique, I suggest a Google search and looking up Project Management Institute. There are a couple components of project scheduling. One is activities, the other is dependencies. Activities can be defined as any activity that will take time and resources. On the other hand, a dependency is how one task depends on another to start or finish. The most common type is the finish to start dependency. One task must be completed before another task can be started. A lag time is the amount of time a project must rest to be completed. Dr. Howard's experiment with bacteria in petri dishes, the bacteria needed lag time to grow before the next task can begin. A lead time is how far a dependent task can lead the completion of a prior task on which it depends. Lead time is kind of a technical term used in project management. In normal use, lead time usually means how much advance notification one needs to give someone. In project management, it refers to how much a succeeding task can lead the completion of a dependent preceding task. The book, for example, talks about how writing in Dr. Howard's lab construction can lead the construction of the walls themselves. As the walls are put up a room at a time, wiring can be strung through those walls. Therefore, the wiring can lead the total completion of the walls. And finally, let's talk about milestones. Milestones are important events in a project's life. An important thing to keep in mind about milestones is that they tend to require activities around them like reports, conferences, administration of payments, and the like. The 3 components of project schedules are the project network, the critical path, and slack or float. The project network is the arrangement of project tasks to one another. This kind of network is shown in the Gantt chart near the end of this presentation. The path is critical because any changes to it will affect the end date of the project. Often resources are taken from activities off the critical path to shorten the path. This happens by adding resources and shortening time to do the tasks, or to keep the project on schedule when it has fallen behind. When this is done, you have to be very careful that the tasks losing resources do not now take so long that they become critical and the new critical path. Slack is the amount of time a task can hold off starting without affecting the project's finish. This is shown in the Gantt chart near the end as a line connecting activity or taskbar. The longer the line, the more the slack. This table shows how the WBS looks in outline form. The major jobs are composed of more minor tasks. 1.0 physical plant is the major job of a project. Shown here are 2 similar, smaller components, 1.1, which is prepare the plant, and 1.2, develop the infrastructure. Each of these, in turn, are composed of still smaller tasks. The smallest tasks are the actual activities of the project. The higher order tasks are the summary, larger tasks that are composed of smaller tasks. It's good to think in terms of the whole job. All larger jobs that need to be done for a project first, and then all the smaller component tasks needed to accomplish them. The smaller component tasks, in turn, are often dependent on one another in terms of which one must be done first, second, third, and so on. There are a number of steps that need to be taken when developing a project schedule. The next few slides work through these steps as they apply to developing a Gantt or bar chart with dependencies shown. Review and revise time estimates. As one begins the task of scheduling, it is always best to review the time estimates given to tasks. In the Gantt chart, use the best guess estimate only. It's also important to really consider the dependencies. Which task depends on others to be done? When tasks are clustered together, dependencies are easier to see. Which phases depend on others? Just as the smaller component tasks are often dependent on one another, so too are larger project jobs. When these larger jobs are arranged through time, they can often cluster into project phases that build on one another. Let's go back and think about Dr. Howard's project. The laboratory needs to be constructed before the operations in it can begin. Laboratory construction constitutes a project phase upon which another phase is dependent. Now we're going to talk about how to develop a Gantt chart. Or another way to state it is to construct the network of project activities. This refers to actually building the graphic that represents the project schedule. The Gantt chart is used here to illustrate this building process. Gantt charts are done on a project calendar. The project calendar is represented by columns on the Gantt chart table. Often they are broken down by day, but can be summarized into weeks or months. Each task is represented by a bar. The length of the bar equals the length of the task. Often project calendars include non-work days such as weekends and holidays, and the task bar is extended across these days without counting them. For purposes of discussion, you can think that all bars initially begin at the start of a project. Because some activities cannot begin until another has ended, these tasks must be moved across the project calendar and placed in proper relation to the preceding task upon which it depends. Arrows also show the dependencies. Gantt charts technically do not need to have arrows connecting tasks together. Some project management software connects them using the arrows. Essentially, the longest activities, or bars, are followed in sequence. When tasks come together, the longest path is chosen. This process is repeated until the end of the project. If you look in our textbook in Appendix A, you will see a detailed explanation of this process. Calculating the critical path using the critical path method. The next two slides show another project. It was constructed using Microsoft Project 2000. The project calendar is shown at the top in terms of days arranged by week. Non-work time or weekends are also shown. The WBS in outline form is shown at the left. The columns left to right show the project number of each task, starting with 1, the WBS outline number, the task label, and the amount of time it will take to do the task. Larger summary jobs are shown as black bars across the calendar. The critical path is shown, darker gray bars across the calendar. There are no free workdays on the lines connecting them. Dependencies are shown by the arrows connecting the bars. Slack is shown by the lines extending from one bar to the beginning of a succeeding bar. These lines show the number of free work days. An example of lead time is illustrated on the critical path with 1.2.1 framing and 1.2.2 wiring. Schedules can be used for a number of purposes. It helps to visualize the project as a whole. The preceding slides show how the whole project can be seen when the schedule is in place. The project components are indicated visually, including project phases, project dependencies, and communicating with stakeholders. This kind of schedule makes for an excellent communication aid for all stakeholders. Team members can see where their jobs are in the project and who depends on them. Suppliers can see when resources are critical. Clients can see when project components are to be completed. And the leadership team can see how the project is to proceed. Projects, being unique, are always revised in one way or another. When plans are first laid out, there is usually a lot of activities that can be done more efficiently and can be started and finished in such a way to shorten the project. When firm project timelines are given, the schedule is the main tool for rearranging the project tasks to meet the deadlines required. As the projects move forward, revisions often have to be made. The schedule is the principal tool for doing so. In project management software, revisions can be made in a what-if fashion and the consequences immediately calculated. Let's end up this chapter by talking about command and control. The project leader makes use of the project schedule to make sure critical tasks are being accomplished on time. Resources are going to be delivered properly to forecast possible bottlenecks. Hold accountable those leading various parts of the project. The project leader uses the schedule to make sure critical tasks are being accomplished on time. They use it in a number of ways, but let's talk about three in particular. First, they use it to make sure the resources are going to be delivered on time. Second, it's a wonderful tool to forecast possible bottlenecks. And finally, it can be used to hold accountable those leading various parts of the project. As I said, there are many other uses for the schedule, but these are really three critical uses.